one really nice feature of these containers is that one virtual machine can run multiple containers at the same time, but they're isolated in a way that they don't interfere with each other. There's always that trouble, isn't there, when you, back in the bad old days of installers, that if you install two applications on the same computer, one of them might mess up the other one and break it in some weird way. Whereas there's really good isolation between containers, and you can pack a lot of containers onto a single virtual machine. So it's a very efficient way of running your application. Another really nice thing about containers is that pretty much any open source or third-party application that's designed for the cloud has already been packaged into a container. So you've got the ability to just easily consume it. If you can run containers, not only can you run your own code, you can run pretty much everyone else's code as well. So if you want to use Elasticsearch or Redis or Postgres, it really just is as simple as just asking Docker to run the latest image for that piece of software for you. Again, you don't need to worry about how do I install this thing, just run the container. And another nice thing, particularly for .NET user groups, is that it's both Windows and Linux. So although containers has the most traction and has been around the longest on Linux, you can create Windows containers and run containers on Windows. And that's relevant for any of you who are still using the classic .NET 4.7.2 or earlier frameworks. I don't know how many of you are still using that. We certainly are. We've got a lot of code that was pre.NET Core, and that can't run on Linux. And so if you want to containerize it, running as Windows containers is your only way of doing that. Obviously, if you're using .NET Core, as I'm sure most of you know, that can run on Linux. So when you containerize that, it's very common to containerize it as a Linux container because they're much more lightweight and efficient. If you're stuck with Windows dependencies, then the containers world can support you as well. How can you host containers in Azure? It's another big topic, this, and there's another one that I've actually got a Pluralsight course on, going through all the options and sort of doing demos of them all. There's lots of ways that you can run containers in Azure. You can, of course, just create a virtual machine, install Docker on it, or create several virtual machines and install Kubernetes on it if you really want to, and run your containers directly on that. And that can be Windows or Linux. Someone's saying in the chat that they've seen Windows containers between 3 gigabytes and 9 gigabytes. Yeah, that's one of their downsides. They can be very large. So if you can use Linux, then go for it. And there's another question about using containers and Docker interchangeably. Yeah, there are other ways, other technologies that can create containers. I tend to use the terms a bit more loosely. I think maybe someone in the chat will give like the purest definition of what the exact distinction between Docker and containers are. But I'm a little bit sloppy in my terminology there. But essentially, Docker is able to run containers for you, and is the main tool that, as a developer, if you're working with containers, is the tool that you're going to install on your computer to run containers. I know that there are some other container runtimes that you can use instead. Azure Container Instances that I mentioned before is kind of a really interesting way of combining one of the main ideas of serverless with containers. And that is to say that you don't need to provision any service in advance. You just ask Azure, please can you run this container for me? And it finds a server for you, and it gives you per second billing. So if you need a container to run, let's say, just to do a batch job, and it's going to run for half an hour and then exit, then Azure Container Instances is great for that because you've just paid for half an hour of compute time. You haven't paid for any more. If any of you are Azure developers, I'm sure you've used Azure App Service, which is kind of their premier way of hosting web apps in Azure. And It's got loads of features for web apps like custom domains and auto scaling based on web traffic. And it supports a whole bunch of technologies out of the box. It supports .NET, PHP, Python, Java. It's got loads of things it supports. So normally you don't need to use containers with app service. But if you do, for some reason, want to, maybe you've written your website in Go, or for some other reason you want a containerized website, you can host your containers on Azure App Service and benefit from all the other web-focused functionality that App Service has to offer. There is also Service Fabric, and there was a very exciting new offering that Microsoft came out with a couple of years ago called Service Fabric Mesh, which I thought was really cool. It was kind of a serverless microservices platform. However, I would say I'm getting the impression that Microsoft are kind of downplaying Service Fabric in preference of focusing mainly on Kubernetes. And that is really because Kubernetes has kind of won the battle, if you like, for being the container orchestrator that people run their microservices on. Although there are other container orchestrators available, if you're running microservices in containers, Kubernetes does seem to have established itself very strongly as the industry standard way of doing that. Even though, as Kevin's just said in the comments, I know that people who use Service Fabric often speak very highly of it. It's got a lot of fans, and it's used by Microsoft as the underlying platform for a lot of their services that they offer. But what Azure Kubernetes Services is basically a super easy way of getting a Kubernetes cluster without having to go through all the hassle of knowing how to install it and configure it yourself. You just ask Azure to give you a Kubernetes cluster. You tell it how many worker nodes you want, so that's how many virtual machines that will run the containers, and you'll build for those worker nodes, so you're not paying for the master nodes, which is a nice cost saving, because in a Kubernetes cluster, you not only have worker nodes, but you also have master nodes that are the control plane for your Kubernetes cluster. But one important thing to say is that even though this is the Azure Kubernetes service, it is downstream Kubernetes. It's not a special Microsoft fork of Kubernetes. So if you're using it, if you know how to use Kubernetes, it is exactly the same in Azure as it is anywhere else that you've used Kubernetes. And in fact, Microsoft have hired Brendan Burns, who's one of the creators of Kubernetes, and he's kind of one of the driving forces behind creating AKS and making sure that Azure's a first-class place to run Kubernetes. So that was a kind of a very rapid overview of the main philosophies of what do I mean by serverless architecture and what do I mean by containerized architecture. And as you can probably get the impression, both seem very good options. So how can we decide what is best to use? If we're architecting a new application in the cloud, how can we pick whether we want to go? So you could imagine an architecture that was 100% serverless, and you said, right, all of my code, I'm going to write it using Azure Functions. And if I need to use databases or message buses, I'll just use whatever Azure has got to offer, or your cloud platform of choice, obviously. And you could construct an entire application in a completely serverless style. But also, it's possible to construct a microservices application in a 100% containerized style. So I could say, right, I'm going to create Azure Kubernetes Service, and in my Kubernetes cluster, all of my microservices, I'm going to containerize them and run them in my cluster. And in fact, you can go further. You can say, if I want to use messaging, maybe I'll use RabbitMQ as a container in my cluster. And if I want a database, I might use Postgres as a container. Or if I want to use Elasticsearch. And that way, everything that I'm using in my entire application is containerized. And one advantage of that is, of course, it's now very portable. It's not really tied to Azure at all. I could take this and I could run it in AWS. I could run it in my local data center. I could even run it on my development machine. However, having said that, when people do choose containers for microservices, it's still quite common to rely on the other services offered by your cloud provider. So if you are using AKS and you want a database, you don't have to find a containerized SQL Server and run it in your AKS cluster. It probably makes more sense to just use SQL Azure database instead of trying to containerize all your databases. Because again, it's taking some of that management overhead of you patching and up versioning your database yourself. So to think about the choice, let's first of all consider what the benefits of picking serverless would be, and then we'll talk about what the benefits of containers would be, and then maybe we'll have a little chance for you to join the conversation and tell me what you've chosen or what you think about this. So what are some reasons for picking the serverless option? Well, one thing I really like about Azure Functions and serverless functions as a service programming models is that they kind of push you in the right direction for creating event-driven, stateless programming. There's nothing that says that you can't do the same in containers, but right from the get-go, Azure Functions is designed for you to think about your application as an event-driven application. Everything that happens is in response to an event. And also it encourages you to code in a stateless way, because you don't know from one execution of your function to the next whether you'll be on the same server. It's quite likely, it's quite possible that you will be on the same server, but it's also just as likely that you'll be on a completely different server. So all of those slightly dodgy practices like holding in-memory caches from one function invocation to the next, it discourages you away from those because it's just not going to work for you everywhere. Also, the fact that it comes out of the box with all of these bindings and integrations really does enable some very rapid development flows. If you want to just quickly prototype something and get something up and running really quickly with Azure Functions, you can. It is a very rapid programming model. It does mean that it's kind of encouraging you to use the services that it's got good integrations with. But as long as you're happy with those and that they meet your needs, then this can be a way of really speeding up the overall development process. It's also the fact that there's a super low cost associated with serverless, particularly at the startup and prototyping phase, where you haven't got huge volumes of customers or huge volumes of data going through your system. You're essentially paying virtually nothing. In fact, Azure Functions comes with a monthly free grant of up to 1 million function executions per month. So it's quite possible that if you're just playing around and experimenting and trying ideas with Azure Functions, your Azure Functions bill is likely to be zero most months. And it's only once you're actually out there in production, you've got real customers that you'll start paying, but that will be in proportion to how much usage your application's got. And of course, the fact that rapid and automatic scale out is built in is really amazing and very powerful. And it just takes the whole consideration of how am I going to automatically scale out without spending too much money. That whole consideration is taken away from you. However, there are some downsides, and one of the disadvantages when you go for a serverless model is the concept of cold starts. So I said earlier that not only does Azure Functions and generally serverless offerings scale up automatically or scale out to many instances, but it can scale all the way down to zero to save money. And so if your application is not being used, there are no servers running your application, but that means that the next person who tries to use your application could have, excuse me, a little bit of a delay while they wait for your application to start up. And those cold starts, it can vary, they can be 10, 20 seconds. Well, that's kind of fine if your application is mostly doing background processing, so it's doing batch processing, scheduled jobs, or handling messages. That's the cold start time really doesn't really matter. But if you're using it as the back end for a website, a public-facing website, then that's a potentially poor experience for someone who's visiting your site. So you want to bear that in mind, whether it's the right choice for a public-facing website. Azure Functions, by the way, does have a premium pricing tier, which you kind of ensure that you've always got at least one instance running to help you get around this problem. But the other thing that you will run into is that even though it comes with a load of great integrations, what you'll find is that sooner or later you are going to need to integrate with some stuff that isn't built in, or you're going to want to integrate in a way that the built-in bindings don't really fully support. And so although the kind of a pipe dream is that with Azure Functions, you'll never have to write all this boilerplate code, the reality is that before long, you will find that you probably do need to write some infrastructure and plumbing code to do the things that the bindings don't quite do right for you. And yes, somebody's just added in the comments here that it's got far less features than ASP.NET Core when it comes to using them as back-end APIs. Yes, I agree. I think you lose a certain amount of control. That's part of the trade-off of serverless. You're giving more responsibility to your cloud provider, and as long as you're happy with the feature set it offers, that's great. If you want more control, then you probably do need to go to something that gives you a little bit more in-depth control over exactly how things are running. What about containers? What might cause you to pick containers instead of serverless? Well, one particular strength for containers is if you've already built an application, and most of us are in a situation, I would imagine, where we've got some legacy code, we've got things we've already built, and the idea of just rewriting it as serverless is not realistic. It would take a long time to just take a legacy service that you might have spent a couple of years building and rewrite the whole thing using Azure Functions. However, one of the really impressive things about containers, Docker as a technology, is the sheer breadth of technologies that you are able to containerize. I don't know if any of you have come across Elton Stoneman, who's one of my friends who creates Pluralsight courses and does a lot of talks on Docker. And he's got some brilliant demos that he does, taking very old ASP.NET 3 and ASP.NET 3.5 websites and showing how they can be run in containers. It's very easy to take a legacy service, write a Docker file for it, and within a couple of, even if you're new to Docker, it's probably only a couple of days of work, and you've got your legacy service running as a container. Also, as I've already mentioned, the fact that so many other third-party bits of software are available as containers means that it's really easy for you to just adopt other technologies. If you're using serverless, as I've said, most of the time you're going to be looking at what services does my cloud provider offer, and I'll just use those. I'll use Cosmos DB or SQL database. I'll use Service Bus for messaging. Whereas if I'm using containers, I can pretty much pick any technology that I like. I can use Elasticsearch, I can use RabbitMQ, I can use Postgres. Anything that's containerizable, I can easily adopt that into my architecture. I also think, particularly from a microservices perspective, that Docker has got some really good advantages. So with microservices, if you're a developer and you're working on a microservice, hopefully you're able to work on it in isolation and test it in isolation. But very often you also want to test it in the context of the whole microservices application. So you need to start one of everything. Maybe locally on your machine or on kind of a server in the cloud, you want to start up the whole microservices application. And with Docker, there's something called Docker Compose, where you create a YAML file and you just list all of the services that are part of your microservices application. And when you do that with one command, docker compose up, you can run all of those services. And so you've got a really easy route without having to download and build the code for all the microservices to get all of those services running. And that's certainly something that is a real benefit for some of the systems that I've worked on in the past, where developers have had to get all the code for all of the microservices and separately start them all up just so that they can get everything running on their machine. And it's a lot of effort. So this is a really good benefit, I think, for microservice development in particular. This one, you could argue about whether serverless or containers have got the better security story. One thing that I find when we're talking with customers who are going to use our microservice applications, and they're interested in, tell me about the security of your microservice architecture. If I say to them, oh, it's serverless, and that just means that I don't know what servers it's running on. They're all different servers that are appearing and disappearing all over the place, and they're not on a virtual network. That can make some people quite nervous. Some people prefer the idea of there's these virtual machines that are pre-allocated, they're all on a virtual network, and all of the code is running inside this boundary on this network. That's not to say that you can't adequately secure serverless, which you certainly can. And in fact, with Azure Functions Premium, you can put your functions onto a virtual network as well. But I've generally found that this is easier to explain to people who are interested in understanding the security and threat models of your microservices, that they're all running inside one Kubernetes cluster. And one really great thing about buying into the not only the Docker ecosystem, but Kubernetes as a platform for running your microservice is that over the last several years, there's just been so much innovation in that space, so many added value, extra tools. Some of you may have come across the concept of service meshes, which you can install onto Kubernetes and add extra capabilities and powerful features to your containerized microservice applications. There's lots of ops tooling and monitoring tooling and tooling to help you with development. Visual Studio has got some great integrations with developing in containers. And so if you go the containers route, you're buying into the ability to pick and choose any of this ecosystem of additional tooling and take advantage of it. In terms of are there any downsides to containers? One thing that I would say, particularly with Kubernetes, I wouldn't say Docker's that hard to learn. You can learn Docker relatively quickly. But Kubernetes is quite a complicated beast. And I don't know if any of you have tried to learn it. I certainly found that the more I tried to learn about how Kubernetes worked, the more I realized how much additional stuff there was for me to learn. And really, primarily as a software developer who wants to focus on just making the application, I don't really want to have to deal with the complexity of understanding all of the ins and outs of Kubernetes. So I kind of want that really to be the responsibility of the operations team who are running the application. And if we've got time, we might talk right near the end of this session about some of the ways that the complexity of Kubernetes can be abstracted away a little bit from developers so that you don't necessarily need to think about it so much. But what I'll do there, as we've been going a little while now, pause for opportunity for any of you to unmute your mics or write in the comments and let me know what your thoughts are. What options are you building with serverless? Are you building with containers? Or are you planning to go to them? And if so, what are you feeling is the right choice for you and why?
I'll talk. So we've got a mix of both. And we find, I suppose, containers is a lot easier to spin things up locally than kind of functions anyway. Because you can just have it all kind of like packaged up, ready to go. Just do Docker run, and it just runs. There's a lot of other kind of function stuff. You need the runtime and everything else downloaded. I think they're doing some changes around that. So they're doing in version 4 of Azure Functions, I think they're doing out of process for .NET, I think it is. So that means it's just going to call an exe or whatever else and pass some stuff to you, and then you pass it back. So you don't have to have the runtime and everything else packaged in with it. I don't know if you know much about that.
Well, a number of the other languages are supported in.
Yeah.
Bringing that to .NET, bringing that to the .NET functions.
And that's how all Lambda works as well. So I'm not too sure about the Google Cloud Functions. But yeah, Lambda kind of does that. It just passes you a blob of JSON, the other side just deserialize it and shove something back.
Yeah, we've got a comment here in the chat about with serverless, the overhead of deploying them. Yeah, I think that is one attraction of containers, that there's this standard way, one way to deploy everything, as opposed to if you've gone for Azure Functions, you've got to learn the Azure Functions way of deploying stuff and making sure your config is up to date. Just reading a couple more of these comments and then we'll move on. Yeah, so someone's mentioning you can run serverless inside Kubernetes. We'll talk about that in a moment, actually. And yeah, if you've got customers who don't want to be cloud hosted, then containers is obviously much more attractive and easier to migrate your legacy code to. But and again, Kevin's mentioned deploying Azure Functions inside containers. And a question here saying, is it possible to develop locally with serverless? The answer for Azure Functions is yes. It's actually very, very nice developing locally. If you build an Azure Functions application, you can run it locally on your machine, and you can connect it to the Azure Storage Emulator and the Cosmos DB emulator, so you can be completely local. So if you're just working on one Azure Function app, I would say it's very easy to work locally. Where it perhaps loses out a bit compared to Docker is that if that one Azure Function app is part of a bigger microservices application that has many other Azure Functions apps, how do you run all of those as well to run your entire application? And I think Docker's just got a more slick solution to that. But there's nothing stopping you working locally on an entire microservices application that's built in serverless. So can you have the best of both worlds? And the comments have kind of preempted a few of these things. So first of all, you don't have to choose. It's perfectly allowable to have hybrid architectures. If you want to have some serverless and some containers, then you can totally do that. And in fact, that's kind of the approach that I'm using in a lot of systems. One thing that I built a while ago was a media processing pipeline. And so the idea is I've got some video files and I need to process them in different ways. I need to transcode them and I need to extract thumbnails. And what I used was I used Azure Durable Functions as the workflow engine for that. So that was deciding what steps I needed to go through. But the actual heavy lifting of doing the transcoding steps, that's better done in a container, because I can use FFmpeg in a container. And so I combined Azure Functions with, I used ACI, Azure Container Instances, and so I had a containers and functions solution to that problem. Also, as has been mentioned in the chat, you can run Azure Functions inside containers. So when you create your Azure Function app, you can just say, build it as a container, and then you can run that function app inside a Kubernetes cluster. Now that's great, apart from for two caveats. The first caveat is, as I've said, most of the integrations that Azure Functions offers are with other Azure services. So if you're using those other those services like Cosmos DB and storage, then probably you want your containers to also be running in Azure, because generally speaking, for maximum speed and efficiency, you want your databases to be in the same data center as your code is running. But you could run Azure Functions on premises and connect out to Azure, or even to just not use any of the bindings to Azure services. But then there's another bit of Azure Functions, which is the automatically scale out. So when you're running at your Azure Function app in Azure, it's monitoring to see whether, let's say, the queue that you're listening to is backed up and creating more instances of your Azure Function app. And that bit of Azure Functions is now actually also available to run in your Kubernetes cluster. It's called CADA. So what CADA can do is it can do the same thing. It can monitor the kind of triggers that are triggering your Azure Functions and decide that it needs to scale out some additional containers. So you can actually get the auto-scaling bit of Azure Functions inside your own Kubernetes cluster if you want. So if you really like the Azure Functions programming model, but your company has already decided we're doing Kubernetes, you can buy into it if you want to. And Kevin's just said that you can build bindings and triggers to other services outside of Azure. And he's shown an example of a MongoDB. Is that, you created that yourself, Kevin?
Yeah, it's me playing around. It's extension points for it where you can add bindings to for your Mongo database. But the problem is you can't run it in a consumption plan, I think it is. You have to have a dedicated instance. So if you run it on inside of like Kubernetes or hosted somewhere yourself, or a dedicated plan, it runs fine. You can't have it on a consumption-based plan. That's the one problem.
Okay. Right, so that's a bit of a downside, but it's nice to know that you can create your own bindings to extra stuff if you want to. But I imagine, as you said, it's a bit of a trade-off. It's like, is it really worth going to all that effort? And there's quite an interesting question about how you keep database structures in sync when accessing a database from multiple serverless functions. So this is an interesting question because it speaks to the relationship between functions and microservices. In a microservice philosophy, you have this idea that your microservice owns its own data. So there'll be certain tables in the database or an entire database that is owned by a single microservice. However, your microservice might be made up of multiple functions. And so you're right to ask, how do you deal with migrations? What you'd have to do is make sure that you run your migrations in a safe way. So if you're running migrations live in the cloud, you run your migrations in a safe way that doesn't conflict with any functions that are using those tables currently. Otherwise, you have to kind of go to the upgrade approach where you stop all your functions temporarily, you migrate the database, and then you upgrade them all to the new version. But generally speaking, I would run the database migrations separately and try to run them in such a way that I'm only making, wherever possible, additive rather than breaking changes to the schema. Whenever you're dealing with cloud stuff that you want to keep running 24/7 and you want to have kind of zero downtime upgrades, you want to be thinking about your database changes as always making non-breaking changes, always adding extra columns, adding extra tables, but not taking them away or changing the types in such a way you're breaking all the code that's actually accessing that table. And another interesting service just to mention on the combination of the idea of serverless with containers is that in Azure Kubernetes Service, if you find that your AKS cluster is kind of over busy, you're using up all of the capacity of your cluster, you could add additional worker nodes to your cluster, but you've also got the option to connect Azure Container Instances as this kind of like elastic pool of virtual capacity. And so you've got the ability to suddenly and very extensively scale out to a lot more container hosting capacity. And that would be particularly useful if you had these kind of very large and unpredictable bursts of load that your cluster needed to deal with. So that's something that's worth considering if you've got a workload that's like that. Yes, and as Kevin rightly points out about databases, of course, that's one of the big attractions of going with a document database. You've got this schemaless approach that you can just start writing documents with new schemas, and as long as your code copes with the old documents that haven't got whatever the new columns or bits of data properties are, you're just good to go. It takes that extra headache out of the upgrade process. Okay, so obviously it's great talking about serverless and containers, and what would you use if you were starting a completely greenfield new project from scratch. But I guess a lot of us are in a situation where we've not got that luxury. We've already built some code. Maybe it's kind of more in the monolithic style, sort of one gigantic service that runs on a super powerful VM, has got one big database, and it's got loads of code, and it all has to be deployed and published as one gigantic lump, all at the same time. How can we get to microservices? And if we want to get from that point towards microservices, should we be looking at things like serverless or containers, and how can they help us? And I haven't got any like super profound insights on here, but basically there's two main strategies that I use to move kind of legacy systems more in a microservices and modernizing the technology kind of direction. And the first is to augment your monolith with new microservices. So you basically say, our monolith is what it is. It's huge, it's got loads of functionality in. But whenever I'm adding a new feature to my system, what I want to do is add, wherever possible, add a new microservice. So add something from the outside. And this is actually one area where Azure Functions can really shine, because what you can do is, if you've got, say, a new feature that can be implemented asynchronously, you could, from your monolith, just pop a message onto a queue and then create an Azure function that listens to that queue and does the new functionality. And the advantage of using Azure Functions for that is that you're not really adding any significant cost onto whatever it is that you deploy to the cloud. If you're deploying a very large and expensive virtual machine to run your monolith, you're not also having the cost of adding an entire AKS cluster. You're just adding a couple of Azure Functions. However, of course, you can do exactly the same thing with containers. You've got somewhere to host those containers, whether it be an AKS cluster or using Azure Container Instances, or even just installing it on the same virtual machine that's running your monolith. It is possible to augment a legacy system by adding new functionality as containers. And that can be a way of very slowly starting to introduce kind of new paradigms to your development team. Because often you find a development team that's been working in a more traditional architectural style for a long time, they need time to learn about the new paradigms and patterns of how to develop serverless code or to develop containers. And so it can be a good, gentle way to introduce some of these ideas into your architecture before you take kind of more radical steps to go further. But if you do want to move a bit faster, and often you will want to move faster, particularly if your monolithic solution is causing you problems and you're actively trying to get away from it, is to actually identify areas that you can extract as microservices. So you identify an area of functionality and say, right, I'm going to take this and it's now going to move out of the monolith, it's going to live separately, and it's going to be its own microservice. And this is actually something that I think containers can really show its strength, because you don't want to, at the same time that you're doing this extracting process, also have to completely rewrite the code using Azure Functions. With Docker, you can take all of the code as is and move it into a smaller project, build that, containerize it, and run it as, so for example, in an ASP.NET application, you might take just one controller from a really large ASP.NET application, just take one controller, move that into its own project, containerize it, and then that's running as a microservice. And you've successfully taken one piece out. However, having said that you can extract bits from a monolith, from my experience, it can be quite a painful process. So I've just added here a few tips and things that I've learned along the way. One thing that I find that you run into a lot is tight coupling. The nature of a monolithic application is that all of the code is in the same place. And that actually gives developers the freedom to just make all kinds of connections and couple things together that from an architectural perspective probably shouldn't be coupled together. And that really bites you hard when you then try to decouple part of the system out into a microservice. Generally speaking, it's the technical debt problem. You know, the compromises that have been made and the shortcuts that have been made over the years now really kind of start to cost you and to get in your way of making future progress. You also run into a data ownership problem. With a monolithic architecture, it's very common basically for you to have one big database that's got all of your data in, and then any of the code that wants to read any table or write to any table just feels free to do so. Whereas with microservices, you give ownership of certain parts of the data to different microservices, and you're very strict about that. And you say only this microservice can read and write from this database, and anyone else who wants the data in that database, they're not allowed to directly go to it. They have to call through the microservice API. And so that can really get in the way of extracting microservices. And in fact, that's led me in a number of times where I've tried to do this to end up with an incremental migration approach where I say, you know what, it's so tightly coupled that I can't do it all in one go. I'm going to take the code that needs to move out and I'm going to move the code out, but there's still going to be a shared database. And then later, I'm going to clean up some of the tight coupling and make sure that all of the data that accesses data in certain tables is in one microservice. And then I can actually make a clean cut and give that microservice true ownership of its own data. So I found that this can be quite a painful process that you have to plan for. And another thing that I've learned, particularly if you've got large development teams and maybe you've got a lot of new developers coming into the project, you need to be very careful to communicate the vision of where you're trying to get to. And so what I tend to try to do for each microservice I create is to write up a very clear kind of design document for it, or a README document that explains what the responsibilities of that microservice are, what data it owns, what its design philosophy is, so what architectural patterns we want to use, and where we're trying to go, what its roadmap for the future is. Because what invariably happens when new developers come to a project, they naturally assume that the code that they see in the code base is the precedent that they ought to be copying. And that means that you can often find that you're going faster in the wrong direction than you are in the direction that you're trying to go. So it's very important, if you're working on big teams and you're trying to introduce new ideas like microservices or serverless or containers, that you invest some time in training the team and making sure everyone has a clear understanding of the direction that you're moving in. So maybe that's another good point for a quick opportunity for people to throw in their experiences or suggestions or questions. Have any of you tried taking a more monolithic application and moving more towards serverless or microservices? And if so, how's that going? What have you done that's worked well or not worked well? We're going to hit all those problems. Hopefully not all of them. Okay, interesting comment from Liam about the strangling pattern. That's actually a really good pattern. Are you able to unmute and just give us a quick 30 seconds on the strangling pattern?
Yeah, hello there. Right, so what you had, the big one that when I joined, and it took 2 years to free it up, was a files BC, bounded context. So that was the thing that was meant to talk to files on the file system. And it owned a load of stuff in the database, or would own a load of stuff in the database if everyone else wasn't writing to it at the same time. So basically, you had to strangle every area of the app that was writing to those files tables that we wanted the files BC to own. And gradually, one by one, they started going through the files API to make anything happen. And at some point, 2 years down the road, you get to the point where the only thing writing to those tables is the files BC. Anything else that needs data has probably got reference copies of it. So there's a few reference tables lying around if they're needed. And that's the point at which you can lift all those files tables that are in probably by now in a file schema out into its own database, and everything works because then everything is talking through the files API to that database, and then you can move the files API into its own deployment, and it then owns that database, and it's the thing that only talks to that database at that point. And then there's lots of RabbitMQ messages going backwards and forwards so they all stay in sync. And it all sounds really simple, but it isn't.
Yeah, no, that's brilliant. It's a very good pattern, and kind of that's what I was trying to drive at. That if people don't know that that's what you're doing, that you're strangulating the old way, you'll often find that new developers can come along and they start to introduce more violations of that responsibility, and they're directly going into that files database. So yeah, it is important to make sure everybody knows this is what we're doing. We're strangulating that. No more of this old way of doing things. We're moving towards this microservice.
And the point is you can only move that data into its own file schema when you own all the rights, because obviously things were still flying around the database. And at some point you just find everything is in the file schema that you need, and now you can lift. Yeah. Anyway, thank you.
Yeah, no, that's great.
Thank you to Ian Cooper, because he was the one doing it all at the time.
Yeah, he's done some very good talks. If any of you have had the opportunity to listen to some of his talks on this kind of patterns, then do so. I found it very useful. And there's another great recommendation in the comments of Sam Newman's book, Monolith to Microservices, which I haven't read yet. So I've read a number of his other things on microservices, but it's definitely one I want to read because I'm interested to know if he's got any additional tips and tricks. I'm sure he has, that I can make use of. So highly recommend it, any of his material on microservices. And then I've only really got one final little section to this this talk that I wanted to cover, and I've just called this a glimpse into the future. And that's really because I think there's a recognition broadly in the industry that although microservices are great and solve a lot of problems, particularly one of the problems they solve is the problems of scaling teams. So when you've just got loads and loads of developers, it becomes unworkable to have everybody working on a giant monolithic application. You need a way to get teams working independently, releasing code independently, and microservices offer a great solution to that. There's a lot of benefits to microservices, excuse me, but there are also a lot of challenges to microservices. They bring a lot of complexity with them, and you know, you've got all of the orchestration problems of how your microservices discover each other and communicate with each other. How are you going to secure them? You've got the development challenges of how do developers work effectively locally. You've got the deployment challenges of what your strategy for building and deploying and upgrading the microservices are. You've got the operational challenges of monitoring all of your microservices and aggregating all the logs into one place. And of course, for every one of these problems, there is a solution, and there are lots of solutions out there. But it does strike me that a lot of teams who are building microservices are spending probably too much of their time solving microservice problems rather than spending more of their time, which is what we'd like, solving the business domain problems, solving actually what the application they're trying to do is. And so I think we're seeing a lot of investment at the moment in producing additional, better quality platforms and tooling that simplify the effort involved in just getting a microservices application up and running in a secure and maintainable and observable way. And so I've just called out three. This is, I think, pretty much my last slide. I've just called out three that I think are worth keeping an eye on and are probably particularly of interest to kind of a Microsoft development crowd, although they're not, only one of them is kind of .NET specific. The first is a technology called the Open Application Model, which is really kind of a standardized way of defining a microservice application. And so the idea here is when I create, if I'm a developer and I'm creating a microservice application, I don't really want to be focusing on the specifics of the infrastructure that it's going to be hosted on. I don't want to necessarily be thinking in terms of Kubernetes in particular and all the way it's going to run on Kubernetes. Instead, what I'd like to do is just like to define my microservice application in terms of these are the microservices that make up my application. These are how they need, this is how they need to communicate with each other. These are the ingress points that I need to expose publicly. And then I define that declaratively using a standard format, and the Open Application Model has kind of got a standard format for defining the components of a microservice application. But then I can hand that over to an application operator using kind of the terminology of the Open Application Model. And they can then run that microservice application, which is all containerized. They can run it on a Kubernetes cluster, or theoretically they could run it on any other microservice hosting platform that knows how to run OAM. And they can make decisions like, shall we use Nginx for the ingress or not? And that decision is kind of taken away from me as a developer. I don't really care. I don't particularly even care about what port numbers are being used and that kind of thing. Really, all I'm saying is here are the microservices. They need to be able to communicate with each other. And there's someone else who's operating that microservices application who's making the lower level decisions about exactly how it's hosted and pieced together. So I think that's one to keep an eye on, and it's got potential to simplify things. Just seeing a comment, Sam Newman's book is very good. Nginx for giving it away recently too. Yeah, I think you're right. I think you can get a free download of that book. So worth fishing around for the link to it. Another one that I've been keeping a close eye on, because I think it's spun out from the Service Fabric Mesh team at Microsoft, is called Dapper. And what Dapper is, basically, it's a set of building blocks that implement a lot of the common functionality that you need when you're building microservices. So obviously, when you're building microservices, you want to be able to communicate between the microservices, make direct calls between microservices. And that means you need to find where the other microservice is hosted. And you need to deal with any retries if that microservice is unavailable. And you also want to secure the communications with the other microservice. And so Dapper, it uses what's called a sidecar model. Some of you might be familiar with if you've used containers. Basically, it sits alongside your application, and rather than your application directly talking to another microservice, you talk to the Dapper sidecar and it communicates with the other microservice. But it's got a number of other building blocks like pub sub, communications, state store, and these are backed by kind of industry standard implementation. So your state store might be backed by Redis, and your pub sub might be backed by Redis, by RabbitMQ, or backed by Azure Service Bus. Again, it's kind of abstracting away a little bit of the underlying platform, but giving you quite a similar model to Azure Functions, just an easier way to integrate with the types of service that in microservices you often need to integrate with. Now, obviously, there are the downsides, like you always have whenever you introduce a abstraction layer, that you kind of lose some of the specific powerful capabilities of the particular platform that you're choosing to use. But I can see things like Dapper really, again, bootstrapping and speeding up the speed at which you can put together a fully functional and production-ready microservices system without spending loads of time working on the specifics of how to, again, set up your microservice hosting platform. And then the final one I've called out just for your interest is Project Tie, which is a more ASP.NET focused microservices platform. But again, it's basically trying to give you a standardized way of putting together ASP.NET microservice applications. Oh, thanks for the link to the book in the chat there. Definitely worth checking that out. But yeah, Project Tie, basically, again, it's simplifying some of the pain points of microservice development. One of the pain points is, how do I know where the other microservices are? With ASP.NET Core, what you often find you do is each microservice has got a different port number when you're running locally. And so then you have to set up all your config to say, this microservice is on this port, this one's on this port, this one's on this port. And then when you're running in the cloud, it's different config that knows how to find the other microservices. Whereas Tie just is simplifying that. It's also giving you an aggregated dashboard. And I think this is a really important thing when you use microservices. You want, one of the things you lose compared to monoliths, monoliths have a great advantage because everything is one process. There's only one thing to monitor, only one place to look at the logs, only one place to look at the CPU and memory usage. Whereas with microservices, lots of processes running all over the place, each with their own logs, each potentially going wrong in unique ways. You want to aggregate all of that observability into a single point. And you can implement that yourself, but really what you want is to just be building on top of some kind of microservices platform that's doing that for you. And so out of the box, all of your microservices, you can go to one place and you can see their health and you can see their logs and you can see what's going on individually with them and the communications that are happening between them. And that you can do distributed tracing even, seeing when one microservice A calls microservice B and then that sends a message to microservice C, to be able to tie that together in the logs that are coming out from each service and see a coherent picture is extremely powerful. And so I'd encourage you, if you are sort of stepping out into the world of microservices, don't immediately try and build your own solutions to all these problems. Of course, I say this from bitter experience. It's essentially what I've done on previous projects. We've kind of run into all these problems and come up with our own custom solutions for them. And of course, that means you're spending more time and effort building your own microservices platform than you are actually building the core business domain that you want to build. So where we're seeing these richer and better microservice tooling that's helping us to simplify our microservice development, do buy into some of these and incorporate them into your microservice applications. And so again, it's really great to hear, is anyone using these or things like these that they want to recommend? Silence. Is anyone doing microservices at all?
Definitely doing microservices, but some of Project Tie is quite new. Dapper 2 and IAM.dev I haven't looked at before. They weren't around when I started. We are using kind of the hand-rolled approach that you're talking about. It's all Docker based. I think functions are very much should play a part in that. Some of our microservices need to be very small. A nano service really, but with microservices, it really depends on the size of the thing whether the function is the right thing or not. If you're doing the nano service approach, then functions make a lot more sense. But microservices, despite the name, tend to be a little bit bigger, and so Docker suits better for us, especially as we're actually doing the Strangler pattern on a COBOL system of 30 years old into a .NET Core environment. So yeah, that's a challenge to say the least.
Yeah, I did say earlier you can containerize pretty much everything, but I don't know, can you containerize COBOL?
Micro Focus apparently do have that capability now, but we're not only have we got 30-year-old COBOL, we've also got a 30-year-old compiler, and the upgrade path from the compiler to get to the newest version of the compiler to do that kind of stuff itself is horrendous. So yes, it is possible if you have a reasonably modern compiler for COBOL, but not for us. No, unfortunately not.
I'm hearing some people in the comments are mentioning console. Does anyone just want to say what that is? It's not one I've used.
We use console in early days. It's a registry, a service registry approach, where you register your service on it, and then you can find it by asking for it. Switching to Docker for us and using Docker Compose completely removed the need for that. We put Trafic, an edge reverse proxy in front of it, and you didn't need console at all. But it is one way of doing it.
Cool. Well, let me just show my final slides, which were just adverts for a couple of my Pluralsight courses. I don't know if any of you've got Pluralsight subscriptions, but I've created a bunch of courses on microservices. And actually, since I put this slide deck together, I've published 2 more, one of which is part of a new building microservices with ASP.NET Core learning path that Microsoft are doing and that Pluralsight are doing. It's got about 8 different Pluralsight authors, each doing a video. So I just did one of the videos, one of the courses in the series. But it's worth taking a look at that if you're going the ASP.NET Core route, because it kind of covers the whole journey of building microservices out from scratch. And also I've made quite a few Pluralsight courses on Azure Functions and one on all the different ways that you can run containers. Oops. And that's just a slide with a few of the links that I've mentioned. So I'm happy to do any more questions or to let people jump in with comments, but that's kind of everything I had to share. So see if anyone does want to do any questions, but if not, then back to you, Kevin.